So we watched the video on dispersion. I just wanted to write some notes down because the demonstrations are really cool. Looking at Newton's original work, but I want to make sure we have this stuff in our notes. So topic is dispersion. And in physics, the word means the differential refraction of white light into its component colors. Okay? The differential refraction of white light into its component colors. So let's just draw the picture of it, and I'm going to point out some additional things that our friend there did not talk about. So here we go. Let's say I have the prism. Now, by the way, it doesn't have to be a prism. You can do this with a bunch of different shapes. It's just the geometry of the prism allows for this to happen really easily. And so here we go. I'll have white light coming in. It does have to come in, as I said, at a very specific geometry for what happens. So what's going on here? Well, the reason why dispersion happens is, so let's just draw what happens on the other side. So the white light comes in, and what do we see on the other side? Well, what we see is the rainbow, but what you'll have noticed here is what color bent the most away from this straight line path, and what color bent the least. Hopefully what you noticed is that red bent the least and violet bent the most. Because what's happening here is at this boundary, and let me just draw a quick normal line here, is that different colors are refracting by different amounts. That's what differential refraction means. Whereas red only bends that much, right? Because it's going to go to a higher end material, so it bends towards the normal. But violet, which I'm going to just represent as blue here, bends more and goes over here. And then there's another refraction here, and so there's your red light, and here would be your violet light down here, and all the colors in between. Right, red, orange, yellow, green, blue, indigo, violet, right? So that's that differential refraction. So what must be happening there? Well, if red light bends the least, right? What do I mean by the least, by the way? Imagine the white light were to continue in its straight line path without having interacted from the prism. Where the red is the closest to that. That's what I mean by bends the least, right? And violet light bends the most. What must that mean then? Well, notice here that these two things, red light and violet light, have the same incident angle, theta 1, but they have different theta 2s. That must mean the n for red is different than the n for violet for this material, that they refract by different amounts. So, which has a higher n, red light or violet light? Well, what we saw in an earlier video was the greater the difference in n, the greater the change in direction. Therefore, we know that the n of this material is greater than this. Violet light changes direction more, so it must be the n of violet light is greater than the n of red light. Well, what about violet light is greater than red light? Oh, the frequency. The frequency of violet light is greater than the frequency of red light. Therefore, we can then talk about this medium is something that's called a dispersive medium. And it's one where the speed of light of different frequencies is different in this medium, such that the n of that medium for that color is proportional to the frequency of that color, right? That proportionality, we're not going to get into it, just that higher frequencies have a higher N. Now, by the way, when I say higher, I don't really mean that much higher. Say, for example, we're talking water. Water is a dispersive medium. We said that the N for water was 1.33. But if you take out the chart of the different media, which I should have had brought with me before doing this video, but I didn't, you'll notice up at top, it says the indices of refraction for various media, and then you'll notice underneath it, it says F equals 5.09 times 10 to the 14th hertz. Why is that? Well, a lot of those media on that list are dispersive media, so it's just talking about what the index of refraction for that color of light is, and that color is around about orange, if you were to convert that into wavelengths and then look it up on the table, right? But, so let's say N for orange is 1.33. Well, N for red is going to be just like not that different. Something like 1.3288. And the N for violet is going to be 1.341 or something like that. We're not talking a huge distinction in N between the violet and the red for these dispersive media. It's just a small variation, but it's a variation that's enough at certain geometries to cause these colors to spread out. Now, we have a dispersive medium. There are media where the speed of light of different frequencies is the same for those medium. We're going to call those non-dispersive media. So for non-dispersive media, all frequencies have the same speed. What is the best example of a non-dispersive medium? That's vacuum. All light travels at 3 times 10 to the 8th meters per second in a vacuum, right? So that is what dispersion is about. It's a common effect. Now you'll notice that in the video that we watched, there was a bar, like we call this a rainbow, but it really wasn't a rainbow. It was just like a little strip of the different colors. Well, why was that? Well, it was because the white light that was coming in came in a nice beam, and because of the geometry of this. When do we get a rainbow? Oh, well, we get a rainbow when white light travels through water droplets in the air. And what's the shape of a water droplet? Oh, okay, right, that's circular, and that's what causes the rainbow type shape. Now, if you think about a rainbow, what color is on top of that rainbow and what color is on the inside of that rainbow? Right? Well, Roy G. Biv, right? The ordering of that is because the red is being dispersed the least and the violet is being dispersed the most. So I put a couple of other videos up on that. It's one of my favorites, the double rainbow guide. And then the double rainbow dubstep remix, which is just entertaining and amusing. Feel free to watch those if you want. If you've never seen them, they're kind of funny. But essentially what's going on in those videos, if this is my normal rainbow and here's my white light, right? And that causes dispersion such that there you go. That's what happens to my red. That's what happens to my violet. And then we have that rainbow shape. Actually, no, this is going to bend away from the normal, so rainbow shape. And then rainbow shape as well over here, separating it out. A double rainbow happens because some of the light here, if this light is intense enough, some of the light energy is actually going to reflect back this way. That's going to reflect back this way and reflect back around and cause a second rainbow. And what you'll notice is that the second rainbow is inverted in color order to the first because of the internal reflections happening within the water droplet. But you need real intense light here for that to happen because most of the light energy is going to escape here, only some of it's reflected back. And that's why you'll notice that the double rainbow is very faint compared to the original rainbow. So it is actually very rare to see a double rainbow, but there's lots of beautiful examples out there of them.